Well, hopefully on this DIY, you ended up looking at it as multiply your last answer by 3 and add 2. So if you multiply, if you start at 5 and you multiply it by 3, you get 15, add 2, you get 17. And if you multiply that by 3, you get 51, add 2, you get 53. And if you multiply that by 3, you get 159, plus 2, you get 161. And if you multiply that by 3, you get 483, plus the 2, you get 485. So those should have been your answers for the first 5 terms. Again, we're just starting with some recursive stuff. So on this first recursive, they're telling me that a sub 0 is 2, a sub 1 is 4, and then watch what they're doing here. They're saying a sub k, so the next term I want, I'm supposed to go back 2 terms, back 1 term, and add them up. So 2 and 4 are the first 2 terms. So my third term is simply to take 2 plus 4 and I get 6. Now to get my fourth term, I take the 6 plus the 4. I only go back 2 terms and I get 10. So there are the first 4. We're supposed to find the first 6. So a sub 5 is the 10 plus the 6, which is 16. And then the last term, a sub 6, is the 16 plus the 10, which is 26. 1, 2, 3, 4, 5, 6 terms. Don't do any more, don't do any less. All right, so here we're just going to plug in a 1, a 2, a 3, a 4, and a 5 everywhere we see an n. So you take your 1 and you're going to plug it in for the factorial and you're going to plug it in for the n. So we have to be careful. There's a negative number being raised to a power, and what is n factorial? So the first term, switch colors. So the first term, if I put a 1 in, I'm going to have negative 2 to the first power plus 1 over 1 factorial. Well, negative 2 to the first power is just negative 2. So I have negative 2 plus 1 over 1, because 1 factorial is just 1. So negative 2 plus 1 is negative 1, divided by negative 1, I get negative 1. So now when I go to do the second term, I can put negative 2, raise it to the second power, plus 1 all over 2 factorial. Now the negative 2 becomes positive. So negative 2 squared becomes positive this time, plus 1 all over 2 factorial, remember, is 2 times 1, so that's 2. So 4 plus 1 is 5 over 2. Then you just keep going. So negative 2 cubed plus 1 over 3 factorial. Negative 2 cubed will give me negative 8. 3 factorial is 3 times 2 times 1, which is 6. So you end up with negative 7 over 6. So there's really not a way to maybe find the pattern. I would just keep writing them out. We have 2 more terms to go. So the next term would be our negative 2 to the 4th power plus 1 over 4 factorial. And so negative 2 to the 4th is 16, positive again, plus 1 all over 4 times 3 times 2 times 1. Now, as you do the factorials, all you really have to do is go back to your last denominator and multiply it by the next integer. So the last one was 321, this is now 4321, so just take 6 times 4, which is 24, and you're going to get 17 over 24. And then the last term is negative 2 to the 5th power plus 1 all over 5 factorial. So negative 2 to the 5th is negative 32 plus 1. Now as the numbers get bigger, or you just want to use a calculator, 5, remember, type in 5, go to math, slide over to the probability menu, get number 4, which is exclamation point, and you get your 120. Or again, take your 24 times 5. So this would be 120 on the bottom, and what you end up with is negative 31 over 120. So there are your first 5 terms. Look them over, see if you have any questions. Now the important thing about summation notation, sum means to add all terms. So when you see this symbol, I don't have to do anything. I can just put that on the test and you know what you're supposed to do. The other part of this is there's a start value down here and there's an end value there. So on this very first example, we're going to go from term 3 to term 6. So start by putting in a 3. So this will be 1 plus 3 squared. The next one will be 1 plus 4 squared. The next one is 1 plus 5 squared. And the next one is 1 plus 6 squared. I know I stop when I get to the 6, when my end value, or in this case, they call it a k, right? It's called the index variable. Could be i's, k's, n's, whatever. But once I hit 6, I'm supposed to stop. Now, the key is the notation, right? The notation is summation. So I'm finding 4 terms, but I add them together. I do the sum. So now I have 1 plus 3 squared, which is 9, so that's a 10. And then you do your 1 plus 4 squared, which will be 17. 5 squared is 25, so this is 26. And then 6 squared is 36, so that's 37. If you add them all up, the sum, you end up with 90. So I don't have to do anything except put the summation and you're going to do the problem. So another summation, this time we're going to start with the 0 term. So start here, end here. So this is simply 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus 1 over 5 factorial plus 1 over 6 factorial plus 1 over 7 factorial plus 1 over 8 factorial. Stop when you get here because I hit the 8. Oops. All the way back at the beginning. This should have been 1 over 0 factorial. I should have start with the 0. So sorry. So we have all of these terms added up. Now there might be easier ways to go ahead and do this on your calculator, but we could just type it all in. 1 divided by 0, and then you can go math 4, 0 factorial, then you can do 1 divided by 1, math factorial. So it's only putting the factorial on the bottom number. Then you do 1 divided by 2 factorial plus 1 divided by 3 factorial plus 1 divided by 4 factorial plus 1 divided by 5 factorial plus 1 divided by 6 factorial. So we have 2 more left here. Plus 1 divided by 7 factorial plus 1 divided by 8. So when you hit that 8, we're going from 0 to 8. We're done. And when you hit enter, you get a 2.71827, which is pretty close to the approximation for E. So you get something 2.718278, getting close to the approximation for E. So again, here's another DIY. I want you to stop the video, check the Moodle quiz, answer that question, and then continue with the last video.